Okay, this is the blowout preventer from the 2010 oil spill in the Gulf. This is the flanges beneath the pipe that was cut. This is the flanges. This is before the cut, and the actual cut would be right along in here. Okay, I've designed a device that will use this outer edge of this flange to create a seal, keeping the oil in and the seawater out, using the under edge of the bottom flange to lock the unit on, enabling it to maintain a seal that will allow the oil companies to have control of the well. In my next videos, I'll move to the test models demonstrating how they work. Hi, I'm Donnie Tucker, and I've got a small demonstration on do for you here today. It's what we're looking at here is a pedestal set up with two pipes. The one on this side will be a high pressure test coming with using a hydraulic pump to pump up 10,500 pounds, somewhere in that ballpark. The other pipe we're looking at on the opposite side is just a simple test with water running it. This one just have household water running up through it. I'll set a device on it that will lock onto this pipe as if it were the oil well in the Gulf of Mexico. My design and what I'm trying to demonstrate here today is I have designed a piece of equipment. If there were ever another spill in the Gulf or another rig were to go down, basically if a rig were to go down would be the closest to what happened in the past, to be able to connect to the well immediately after they cut the pipes above the blowout preventer. If the flanges are good and they cut the pipe as if they did in the 2010 oil spill, I can lock onto it. My device will lock onto it that same day. Now I'm going to back up. We're going to stop the camera just a minute and refocus in on the other pieces of equipment and let you see them. So stop the camera, please. Okay, what I have here is two separate units. Two separate units for two separate tests. The units are, at this point down, are the same. These are machined houses with machine seals in them. The only difference is this unit on the right, my right, your left, will be for a high pressure test. It's all welded connections with a gauge. I can't do the high pressure test on this side on account of having to use a ball valve to let the water run through it as I set the unit down. And the ball valve will not withstand the 10,000 pounds of pressure plus I'm going to put on the unit. It will blow the valve. So that's the reason I'm having it set up with two units. This one here, I will lock it on and put high pressure to it. As you read the gauge, you'll get a zoom in on that gauge, get a close picture showing what kind of pressure it's capable of holding. The one on the left is just that garden and the household water pressure running up through the pipe, simulating as if it were the oil well in the Gulf with oil flowing up through it. Just setting the unit down with liquid going through it. In this case, it'd been water, clear water. And set the unit down. We'll put the locks in, lock it on, tighten the bolts down. The valve will be open while we go test, so the water will run out this pipe. So there's no head pressure building up as I'm trying to lock it on. Once the unit is locked on, then I'll close the valve. Now to stop it. Then it builds pressure. Okay, very same houses, very same seals. Only difference, this one is set up for high pressure, this one is set up for low pressure. This is just a demonstration model to show how easy it would set on and connect. And what would happen if these were built to take to work in the Gulf or anywhere else in the world that may be the case. If another oil rig were to sink anywhere, the housing would be built pretty much the same. Just the connection right here would be the only difference when this thing connects. And be, of course, naturally this is about 1/20th of the scale of the actual oil pipe that the rig went down the Gulf. But it'd be much larger and it'd be flanged, bolt up to the oil company's well pipe, and everything else is, of course, these are built on a tadpole budget. Of course, everything else will be built better. Ensure the quick connection, the simplicity, making it simpler. And we're going to move from here, and I'm going to first go to the water test. So we'll stop the camera, and I'll get the water running, and I'll set this unit on, and we'll go from there. Okay, we got water running. Take you back down memory lane. It was 43 days after the horizon sunk before they were able to cut the pipe. I believe the horizon went down April 22, and it was June the 3rd, if I'm not mistaken, when the pipe was cut above the blowout preventer. So there are paraflanges, directly below where they cut the pipe. And this is not a paraflange, this is actually a collar, more of a collar than it is anything. So the reason I made it so small is to illustrate how little it actually takes to lock on a seal. The bigger the flange, the bigger area I got to lock on to. But basically all I'm using is this outside edge, no matter if it's this big, or no matter how big. The outside edge is all I'm using to seal this thing. So what I'm fixing to do is lock on. This is our low water test. Let me get rid of my little bit of head pressure there. This will be done with a submarine, and of course I'm sure I can simplify it quite a bit more. But basically, once we cut the pipe, would be cut in the ocean away from top of the blowout preventer, leaving the paraflanges as if they did in the 2010 crisis. All I need is a pair of flanges. Water a minute. Also, this is the third time I've reused this seal. Using the same seal 3 times. Just say Fox News, any of the other good networks. Wouldn't call on Donnie Tucker to do a newscast. building pressure on the emergency connection device designed to lock onto an oil well pipe such as seen in the BP oil crisis in the Gulf. The unit will lock onto a pair of flanges and create a seal holding the oil in and keeping the seawater out, and is a much faster way of locking onto a well. We'll connect directly to a pipe being lowered down just by bolting it to the existing pipe connections. No special attachments made. It will be flanged to connect directly to the oil well pipe. What you see, I'm exceeding 10,000 pounds. I'm somewhere between 10 and 11,000. The pump's building up and it'll fluctuate a little bit because 10 is going to be the maximum of the pump. It'll go over a little bit, almost 11,000. Okay, I'm going to stop there. I'm going to shut the pump down. Before I do, I'm going to pan down and let you see the bottom of this thing. See, there's no oil leaking, no leaks whatsoever. The seal is holding. The pump is still holding pressure. Okay, now I'm going to shut the pump off.